Hey guys, I'll try and make this short and sweet for factoring review. Write down what you think you need to. You don't have to write down everything though. Just some reminders for factoring is you need standard form first. You should always look for a GCF first, and factoring is basically FOIL or distributed property backwards, so your answer should be two binomials. And just a reminder for standard form, it would be ax squared plus bx plus c, and a, b, and c are just your integers, and something else to keep in mind is you always want a to be a positive. So your steps for factoring when a is 1 is to factor out a GCF first if possible. Find the factors of a times c that add or subtract to b. Once you know those factors, write out the factored form of your polynomial as your two binomials, and then FOIL to check your answer. So we've got two examples. If you want, you can pause and see if you remember how to do them, and then press play when you're ready to check. So for the first example, because it's negative 24 is a times c, because that's a negative, you're looking for factors that are actually going to have opposite signs to give you that positive 10. So if we have opposite signs, we're really going to be subtracting. So there's two combinations here that actually make 10, but the 4 and the 6 would add to 10. So the combination you want, because you need them to multiply to create negative 24, which is opposite signs. So you would use 2 and 12, and you want your 2 to be your negative. So in factored form, we would have x minus 2 and then x plus 12. And if you FOIL that and check it, it is going to work out. The second one here, if you list your factors of a times c, again, it's a negative 63, so we're looking for opposite signs out of these factors to create a negative 2, which really means you're subtracting. And I know 7 minus 9 would subtract, so my factors end up being x plus 7 and x minus 9. And again, if you factor, it should work out. Go ahead and try this one on your own and see if you can pick the factors that would match this trinomial. So you were looking for factors of negative 30 to give you negative 13. Again, because that's negative, they had to be opposite signs, and it should have been option 3 here. So moving forward, we're going to look at factoring when a is greater than 1, and there's 3 different methods we're going to look at. So some of you might remember, you might have preferred box method, maybe factoring by grouping or guess and check. I'll show you each again just to kind of refresh in your brains, and then you can pick which one you guys like. You don't have to write everything down that's coming up unless it's the method you want to use. So box method as a review is going to have the steps of factoring out a GCF, find the factors of a, c that add up to b like we just did, and then those factors are going to go in these diagonal two boxes once you know the ones that are going to work. And then the first box gets your a term, your last box gets your c term, and then what you do is factor out a GCF of each row and column. Once you do that, those are going to become your factors. So we'll take a look at how this is with examples. So for the first example, there is no GCF, so you do a times c, which is 6, and the factors of 6 that are going to give you b, which is 7, or 1 and 6. So the first box gets your first term, the last box gets your last. You put your 1 and your 6 with an x, and then we're factoring out GCF, so your first row is an x, your second row is a 2, your first column is a 3x, your last column is a 1, which makes your factors here 3x plus 1 and x plus 2. So this is really like if you were using box method to actually multiply. This is just undoing that. And then the next one, you are multiplying a times c. Again, there's no GCF, so it's negative 120. The factors that you're looking for are going to give you 2 when you subtract, and that would be this last group down here. Your 12 and a negative 10 are going to give you a positive 2, but multiply to a negative 120. So first box, first term, last box, last term, and negative 10x and 12x. It doesn't matter where you put your 10x and 12x, they can be switched. And then a GCF of your first row should be 2x, second row should be 3, that first column's 4x, and then the last column is 5. Now, if the first box you come across in a row or a column has that negative, you actually pull it out. So because that first column down here had a negative, I take that out. I didn't take it anywhere else because it wasn't the first part of any of those. So my factors become 4x minus 5 and 2x plus 3 for this. So these were the steps for factoring by grouping. Again, if you want to see it first, and then if you like grouping, you can write these down. You're going to look for a GCF, find the factors of AC that add up to B. That doesn't change. Then you write the AX squared term and the C term, just like you kind of would have done before. But then when you find those terms that are going to give you B, they go in between your AX squared and C term, and then you group and you factor out GCFs, and then you write your factors. It's very similar to box method, so just take a look at this, and if you like it, this can be your method. Okay, so the first example, no GCF, AC is negative 12 and B is 1, and because AC is a negative, you're looking for a group that has opposite signs, and you would subtract to get 1, which makes negative 3 and 4. So what you do is you write your first term, 2x squared, your negative 3x and your 4x, you just write next, It doesn't matter the order again here, and then your last term is your 6. And this would be like if you FOILed, these would have been 4 parts of FOIL that would have given you that trinomial that you started with. And then what we're going to do is we're going to group the first 2 and the last 2, and then we're looking for a GCF of this first group, which would be an x. And if we took that out, we would be left with 2x minus 3. Then we're looking at GCF for the second group, which would be 2. And then what would be left over if we took out a 2 is 2x minus 3. So then what ends up happening is the x and the 2, the GCFs that you had of each group, that's actually one of your factors. And then the 2x minus 3 and the 2x minus 3 should always be the same, and that's actually your other factor. And what this would be like is if you took these two binomials and you took x first by 2x minus 3, it would look like this, and then 2 times 2x minus 3 would look like that. So it's really undoing distributive property. The second one over here, the factors of 48 that give you negative 19, and because 48 is a positive but b is a negative, you're looking for 2 of the terms to, or factors to have the same signs, and you would be adding to get that negative. And since it's a negative, they're both going to have a negative sign. So it looks like negative 3 and negative 16 work. So again, you start with your first term, those 2 factors that are going to give you a times c, and your last term. And then we're going to go ahead and group the first 2 terms and the last 2 terms. And we're going to take GCF. So GCF here would be x, we would be left with 4x minus 3. And then a GCF in the second group, because of that minus sign, you're going to keep it a minus, and then your GCF here would end up being, and I just saw I'm missing an x, sorry, your GCF here would be a 4. And then if you took out a negative 4, a 4, you would be left with 4x and then minus 3. So those 2 GCFs become one of your factors, which is x and minus 4. And then your second factors, remember they should look exactly the same, would be 4x minus 3. The last method is guess and check, and it's kind of what it sounds like. So these are your steps. You're going to do the same first 2 steps, and then you're going to find the factors of AC that add to B, but then you find your factors of just A and just C, and you're kind of using a combination. So that's why it's called guess and check. You're looking for the way that you can multiply one of the A factors by one of the C factors, and then the second A factor by the second C factor to get those values that you need for B. So it's probably easier to see it than read through this, so we'll go ahead and take a look at these. And again, you don't have to write these steps down unless this is the method you choose. Okay, so again, we had no GCF for the first example, so we do our factors of AC, which is 24, that give you 11. Everything's positive, so that would be a 3 and an 8. And now what you're going to do is you're going to list your possible factors of A, which is 1 and 4 and 2 and 2, and your possible factors of C, which is 1 and 6 and 2 and 3. And when you FOIL, it's the first term times the first term, and if that creates 4x squared, then one of these 2 sets, 1 and 4 and 2 and 2, have to be those first 2 numbers. And then when you multiply your last times your last, you're going to get 6, which means it has to be one of those combinations of factors of 6. So if we know we're trying to create a 3 and an 8 for our middle terms, then we're trying to pair up one of these groups and one of these groups to make a 3 when you multiply, and the other one to make an 8. And so I'm looking right here, and I realize that I can make a 3 by doing 1 times 3, and then I need the 8 by doing the 4 times 2. So if I know that, then I know that it's going to be a 1x and a 4x for my first 2 terms to create 4x squared. And then the 2 and 3, you've got to be careful. You want to make sure that it's going to be the 1 times the 3. So I'm going to put the 3 in the opposite binomial as the 1, because when you FOIL, it's the opposite ones that it gets multiplied by. And then the 2 goes here. All signs are plus since everything here was positive, and if you FOIL and check that, you're going to end up getting that to work out. The next one here, so the factors of AC, 60, that are going to give you 19, look like 4 and 15. If I list my factors of 5, this one's nice because 5 is prime. So what that tells you anytime you have a prime number is that has to be the first 2 factors anyway. There's no other group, so those have to be those terms. 12 gives you either 1 and 12, 2 and 6, or 3 and 4. And what I needed to create was a 4 and 15. So if I have a 1, this is kind of easy, and I needed to create a 4 and a 15. The only way I'm going to be able to use a 1 and create a 4 or a 15 is if I do my 1 times 4. So again, if my 1x is on the left binomial, my 4 is going to go on the right, and then my 5 and my 3 are going to get multiplied to be that 15. All signs are positive here, so plus and plus. The only thing with this is watching signs. If there are negatives here, you've got to be careful with those. But that's guess and check. That's my favorite. I know not everybody likes it, so if you don't like this, then stick with one of the other 2 methods. Okay, I have these up here if you guys wanted to just pause and then try a few of these. You don't have to do them all if you think you're good at these. If you want to try them all, that's fine. Press play when you're ready to check your answers. Okay, so the first one should have been 3h plus 8 times h minus 2. The second one should have been 5p minus 2 times p minus 4. The third one should have ended up being 2z plus 1 times 3z minus 4. And your last one, a, was actually 1, so that was easy. It should have been r plus 16 and r plus 2. Next, we're going to take a quick look at factoring when you do have a GCF. So none of the other ones did, but that's the first thing you should pay attention to and always look for. So in this first example, you do have a GCF of 2. So when you take the 2 out and divide everything here by 2, you're left with x squared minus 5x plus 6. At this point, you're going to use any of your methods you prefer for factoring, but I'm noticing that at this point, a is 1, so this one's a really easy factoring. You are just finding the factors of AC here, which is 6, that are going to give you b, which is negative 5. And because AC is positive, they have to be the same signs, so I know it should be x minus 2 and x minus 3, because those two same signs give you a negative 5 when you add, but a positive 6 when you multiply. The next one, again, you're looking for a GCF. It should be 3 and x, since all terms have a 3 and an x that they can be divided by. That leaves you with x squared minus 4x minus 12. And again, because now a is 1, you don't really have to use box method or guess and check or grouping. You were just looking for the factors of AC here, which is just negative 12. That are going to give you that middle term, which is negative 4. And they have to be opposite signs so that you can create that, and I'm sorry about how sloppy this is. And so I know factors of 12 that are going to give me 4 are negative 6 and positive 2. And if you check it, then you can FOIL and just double check to make sure that's right. Another thing to keep in mind with GCFs, make sure the GCF is listed as one of your factors. That's really important. It is still a factor. Later we'll talk about it as a solution, but that is definitely still a factor. It needs to be part of your answer. So if you wanted to try these two on your own, there are GCFs. Practice those, and then you can press play when you're ready to check. Okay, so example 3 should have been a GCF of 3, and then your two factors should have been 3x plus 4 and x plus 1. I have box method shown and kind of guess and check up at the top as well. I did not show grouping, but it's very similar to box method. And the number 4 GCF was 2x squared, and then your factors should have been 2x minus 5 and x minus 1 along with your GCF. And then that's it for factoring with GCFs. Next, I just wanted to kind of review prime trinomials, and that's when there's no GCF and no factors that will work, which means you technically can't factor it for now. And if you want to determine if it's prime, you're checking for factors. So if you do a times c, like in this example, which is 5, and b is 2, and you try and look for factors of 5 that give you 2 and there are none, then we call that prime. If there is a GCF, it's not prime. You just take the GCF out, and that's it. And then the last thing I wanted to show you guys was remembering how to factor your special cases. So factoring a difference of squares, the way you would identify this is look for a GCF first always, and then if there's two terms with a subtraction in the middle and the first and last terms are perfect squares, then that would be a difference of squares. The way you factor a difference of squares is obviously GCF first, and then all you do is take the square root of the ax squared term, and then you take the square root of the last term, the c term, and you write opposite signs. Since there's no middle term here, it means that they were the same exact two binomials, but opposite signs, which canceled your middle term out. So practicing factoring a difference of squares, the first one here, you see that x squared is a perfect square, 121 is a perfect square, there's a minus in between. So what we do is we just take the square root of each and write your two binomials with the opposite signs, which means that middle term canceled to make a 0. So x plus 11, x minus 11. The second one, be careful. These are both perfect squares, but you have to do GCF first, and a lot of people forget to do that because they see these perfect square numbers. So when you take out 4, you're still left with a difference of squares. You take the square root of each, and you have opposite signs. Number 3, no GCF, but they are both perfect squares with a minus in between. So we take the square root of each and put opposite signs. We get 10x plus 3 and 10x minus 3. The next one, these are both perfect squares with a minus in between. So z plus y and z minus y. And then your last one, it's not perfect squares now, but there is a GCF of 50. So if you take that out, then you're left with a difference of squares, and you can take the square root of each and have your opposite signs and be done with that. And lastly, we're going to look at perfect square trinomials, and the way you identify these is obviously looking for GCF first still, and then if your first term's a perfect square and your last term's a perfect square and it has to be positive, and then your middle term would be the product of the square roots. So if you take the square root of the first and last terms, you multiply them together and double it, that should be the middle number. So let's take a look at how you would factor these. Your steps, again, are GCF, take the square root of ax squared, take the square root of c, and then you put the same signs that the b term had in your two binomials and you FOIL to check. And this is the one where your two factors are exactly the same, so you definitely want to just make sure it works for that middle term, and if it does, then you write your factors out and you're good to go. So just practicing some perfect square trinomials. The first one here, the first term's a perfect square, that would be r if you square root it. The last term's a perfect square, that would be 4. So if you actually take r and 4 and multiply it, that's 4r, and then double it, that's going to give you 8 in the middle. And I know that's a -8, and that's fine. That just means when you write your binomials, they're going to both have minus signs. So this answer should be r minus 4 times r minus 4. You can write it out as two binomials or write it this way. Your second one here, there is no GCF, but we've got a perfect square, and positive. So we square root each of those, which would make a 2D and a 5. And we want to make sure that that middle term is 2D times 5 doubled, and 2D times 5 doubled is 20, so we know it works. Our third one, again, perfect square, and positive for C. If you square root each of those, that gives you 3r and 4. The middle term is 3r times -4 doubled to give you -24. Next one, square root and square root would give you n and 9. You take the square root of those, or sorry, you multiply those and double it, it gives you 18n in the middle, and you know you're good to go. Number 5, no GCF again, so perfect square and positive for A and C. You square root them to get 4x and 7. The sign matches the middle, and if you multiply 4x times -7 and double it, you're going to get your -56. Your last one, not perfect squares right now, but there is a GCF, so this is where you want to definitely look for it first. And then if you notice that you've got perfect square, and positive, you should be able to just square root each of those to get r and 3 and double, multiplying them and double to make sure it gives you 6, and if so, then you can factor this way. So that is it for all of our review of factoring. Hopefully a lot of this came back to you, and we'll take a look at where we can go from here next class. Thank you guys.